All right, so with conic sections, that word conic kind of comes, we get that word cone in there. And basically, you take two cones and you stack them up on their corner there, their vertex. And then from that, we are going to slice these cones. So imagine just taking like a blade and slicing them and then looking at what you get. Like say if it were a solid block of cheese like this and you were to slice it, we call that a cross-sectional slice. And we talk about the shape there that can be formed. There's actually four main shapes that we can form. The first one is circles, which if you think about it, if you slice it completely horizontal like this and look down, you would get a circle. We have parabolas. Now we've studied parabolas a whole bunch already, but if you slice it maybe vertically at an angle or something like that, you usually get a parabola there. We have ellipses. And then we have hyperbolas. Hyperbola. Now, with each one of these, we will define them as we study them, and it's basically what we're going to be studying over the next 3 or 4 weeks. We're going to start today with circles and go from there. We've studied parabolas a whole bunch already, but we're going to study a little bit more. Circles, I have purposely put off. Normally, I start that in the fall in chapter 1, actually, because our textbook briefly mentions circles and the equations of circles. And then in the spring, we see them again, just like with parabolas. However, this year, starting late, I decided to skip over circles in the fall and then kind of just tackle everything right now as we hit this chapter right here. So today we're going to talk about circles. We're going to define it. And then we're also going to talk about equations of circles and how we can use those. And this will, all of these have their similarities and their differences. And they're all kind of like that conic section family there. So the first thing we're going to do is we're going to define what a circle is. And I'm going to start you off with the definition and see if you can complete it on your own. A circle is a set of infinite points that, I'll let you see if you can think about how to finish it there. I'll give you a second. And so it's a set of infinite points. Imagine just drawing a bunch of infinite points in here. That doesn't really do me any good. What we want are an infinite amount of points that are the same distance away from a central point, or a better way to say same distance is use the math word equidistant. That R, I should have the word R in here, are equidistant from a center point. So here's our center point, and then if you start drawing a bunch of points that are the same distance away from that central point there, so they're equidistant, then you end up getting a circle as you make that a solid line. There's so many points, it becomes a solid line. And then of course we have our radius there. And this is going to set us up to write out the equation of a circle, that being defined there. Equation of a circle. Now you've had this in geometry, and this is basically all this is today is a review of the stuff you've had in geometry and equations of circles. But if we say, here's our circle, and we're going to label its points where the center is right there. We're going to pick any point on the circle we want, and we're going to call that x, y. And the distance between these 2 points is going to be r. That stands for radius, right? And then this spot right here, we call it h comma k. We could call it x, y again, but then it gets confusing with a point that's on the circle. So h comma k is just a specific point, and it represents the center of that circle. In fact, when we look at all of these conic sections right here, they're all going to have an hk in it. For circles, well, let's go ahead and write out the equation of a circle, and then we'll come back to that. The equation of a circle is going to be x minus h quantity squared plus y minus k quantity squared is equal to the radius squared. So notice on this, hk has a special spot on the circle. It's the center, and it's listed right here and here. Just like r is a special location, the r is the radius of the circle, and it's listed right here in the equation. And then lastly, the x and y stand for any point that's on the circle. And in our answers, when we're writing the equation of a circle, we don't really put an x and a y in there. Just like everything else in math, we leave x and y open because it stands for any point that's on the circle. Remember your equation for parabolas. It was y equals a times x minus h squared plus k. Now think about that in relation to this. hk has a special spot on circles. It's right there at the center. On a parabola, it has a special location. It's right here at the vertex, h comma k. hk has a special location on ellipses and hyperbolas as well that we'll see later as we study more and more conic sections. But just like with the parabola, we had hk, and xy stood for any point that's on the parabola, xy. Same thing with circles. It can be any point on there is x comma y, but it has to be on the circle there. And we'll see how that's useful later. So this is our equation for a circle, and that's what we're going to use as we go through these problems today. So the first thing I want to give you is just the equation of a circle, and I want you to tell me what the center is and what the radius is. So I've got x minus 3 quantity squared plus y plus 1 squared is equal to 25. So I want you to list its center and its radius. So looking these, this is, being able to look at the equation, first identify that it's a circle, and then be able to pull out the center and the radius is, it's necessary in order to graph it. So one of your homework problems tomorrow is going to be to graph this circle. So you have to identify the center and the radius, and then it's pretty simple to graph. But a lot of times when students look at this, they want to say, okay, my center is going to be at -3. That's your h value. And if you put that down, be careful here, because if you said -3 was the x value for your center, or the h value, what you're doing is you're just taking this portion out and substituting it in right there. But really, what you want to ask yourself is, what do I put in for h to get a -3 right here? If I put in a -3, I end up with x minus a -3, which is x plus 3. So I must have been able to put in a +3. Put a +3 in, you get x minus a +3, which is x minus 3. So this is going to be a +3. Same thing right here. You're basically taking the opposite of the sign you see there. So this should be -1. And when we put in -1 right here, you get y minus a -1, which becomes y plus 1. So that's my center. It's at 3, -1. And the radius, remember, this is the radius squared. So the radius squared is 25. So if I take the square root of that, I get my radius. and the radius comes out to be 5 there. All right, let's look at another one. Find the center and the radius of this circle. So for this one, we're asking ourselves, what did we put in for h for that number just to disappear like that? So we went from x minus h quantity squared to just x squared. Well, any number we put in here is going to give us something there unless that number is 0. So if we have x minus 0, that's just going to be x. And then, of course, you're squaring it. So our center must be at 0 right there. And sometimes you'll see this as x squared plus y squared equals something. And so the center is at the origin, 0, 0. In this case, though, it's not quite at the origin. You're actually going to be shifting it up 4 because I must have put in a positive 4 there to get negative 4 when I subtract it. And then finally, be careful with these. It's too easy to look at this. You're so used to seeing like single digit numbers for radii. You know, you get square root of 25. You must feel like this has already been square rooted, but it hasn't. This is the radius squared. The radius squared is equal to r. So if you square root this, you'll actually get the radius. So the radius here is root 2. Be careful with those. All right, so that's taking the equation, and what you're doing is you're finding the center, you're finding the radius from it, but we can also, write the equation ourselves if I give you the center and the radius. So let's take a look at one like that. So let's suppose I tell you that the center of a circle is at negative 6, 4. And the radius is going to be at, it's going to be 3. The radius equals 3. Write the equation of that circle. Someone asked, can the radius ever be negative? No, it cannot. It's a good question because it is a distance. So radius can't be negative. Anytime we have something like a negative distance, it's usually something like in physics, but it's not really distance, it's displacement. And the negative is just signifying the direction, just like we had negative angles. It's really telling you the direction you're going around the unit circle, right? But no, we don't deal with negative radius. So that's a good point, because here in a minute, we're going to square root the radius. Well, we did on that last problem, but we'll be more involved in the next problem or the problem after that. Where you take the square root, you're going to take the positive root because you can't have a negative distance there. But good question. All right, one of the things I like to do when I'm writing out the equation of a circle, especially if I already know the center and the radius, is just to write out the equation of a circle and leave out the h, k, and r. Because then I can just substitute in, I can label this hk and this is r, and just substitute those in. So I get -6 right here, 4 right there, and then 3 right here. Now, I want you to clean these up. Don't leave it like that. And by cleaning it up, what I want you to do is square the radius. If you have a minus a negative, make it plus like that, because that's going to become +6. And then if you have -0, just make it like x squared or y squared, whatever it is. So when I clean this up, I end up with x plus 6 quantity squared plus y minus 4 squared is equal to 9. And there it is cleaned up for us. All right, so to write out the equation of a circle, you need two things. You're going to need the center and you're going to need the radius. But we're not always given those things. Sometimes we're just given the center and you got to figure out the radius. Sometimes you might know the radius, but you don't know the center. But also you can have it to where you know neither. So let's look at one where you don't know the center and you don't know the radius. Let's suppose we have a circle. And we know this point right here is going to be, let's make it 6, 9. And then this point right here is going to be 10, -1. And no, this is not drawn like where it would be, I guess, something like that on a ordered pair, on a Cartesian plane, but it's fine. What I'm telling you is that these 2 points are the endpoints of the diameter on a circle. So right here's the center in the middle. And your job is to write out the equation of that circle. So you have seen this before in geometry. This is a very common geometry SOL problem, at least if you've taken the geometry SOL. If you've taken geometry class, you should have at least prepared for it at some point. I know not everybody remembers how to do it though, so I'm going to give you a second to see if you can jog your memory, and if not, I'll show you in a moment. All right, so we want to find the center and the radius. Once I find that, it's a matter of just substituting it in like we did up here and cleaning it up. That's not always obvious what the center and the radius are. So we're going to figure out the center just by going back to, since the fact that this is a diameter and the center should be halfway between the two endpoints of a diameter, we can use the midpoint formula. So if you recall from the fall semester, 10, -1, write down both points, one on top of the other, and then add them. So I get 8 and 16, and then divide by 2. So this gives me 8, 4. That's where that point is, 8, 4. That is the center of the circle. That's not too bad, but now we got to find the radius. And so there's a couple ways we can find the radius. One, we could use the distance formula right here. And this is why this chapter on circles actually starts in chapter 1, because in chapter 1, we talked a bunch about midpoint and distance. And so here it is coming up with equations of circles, but it's more in depth here in chapter 10. So I just saved it for chapter 10. You could use distance formula there, but I like to just use the equation of a circle. And by the way, we can relate the equation of the circle to the distance formula, because that's all it is the distance between here and here. And notice it looks a lot like distance formula. It also can be related to Pythagorean theorem, just like we did with distance formula in the fall. So I'm going to start substituting in things I know. I know that the center is at 8, 4. Let's go ahead and substitute that in. So I've got something -8 squared plus something -4 squared is equal to what I'm trying to figure out, the radius squared. And this time I left x and y open, or I'm going to substitute something in, because I know, you can call this x, y, you can call this x, y, whichever one you want to use, and figure out the radius here. So I'm just going to use 10, -1, substitute that in. There's a 10, there's a -1. And now everything is filled out except for the radius. 10 minus 8 is 2. Negative 1 minus 4 is negative 5. Be sure you're wrapping these in parentheses. When you square a negative, you should be getting a positive number. So if you forget to wrap it in parentheses and you're punching it in a calculator somewhere, sometimes it'll spit out a negative value, and we don't want that. That should be a positive 25, a positive 4. That equals r squared. 29 is equal to r squared, or r is equal to the square root of 29. And here's where we want to take that positive root, because we are talking about a radius there. So there it is. We found the center, we found the radius, and now we're ready to find out what is the equation of the circle. Let's do that. Let me see if I'll just use this paper because I don't want to waste another piece of paper. I'm just going to use these facts right here to fill out this. So this is my HK. And right here is my R. And so I said I'd like to fill it out where I write out x minus something squared plus y minus something squared is equal to my radius squared. And substituting these in, we get 8 right there, 4 right there, and then root 29 right there. And our last step here is to clean this up a little bit. Well, on the left side, nothing really can be cleaned up. There's no minus negatives, there's no minus zeros. But on the right side, we can say, hey, the square root and square, they cancel each other out, and you get 29, which makes sense. R squared should equal 29. Notice in our work right here, we even said it. We said R squared equals 29. Let's try to make that not so crooked. R squared equals 29 before we actually found the radius. And so this is the equation of the circle I just wrote out right there. All right, tomorrow, let's see, we will have a small assignment on this. I'll even post a video in case that was a little bit too fast for you. If you want additional examples, we can go over that tomorrow.